The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
First of all, I'm really glad all these other guys did all my work for me, because that's going to make my life easier. Second, I agree. The construction loads are a big issue when you try and do deflection calculations. What they haven't said yet explicitly is most of the design software that's designing the stuff doesn't handle construction loads very well. So if you're getting deflections off of design software, these gentlemen were using a little different special program and running it twice. You see a little differences, so you have to be careful when you're using design software, and that really helps. The other thing, if we follow what ACI 347, the formwork committee, says about how we're supposed to design formwork, we will practice slab based on that. And I wish that committee maybe could take some help from 435 or some speakers here and would actually put it in the document, because what they say is high loads or excessive loads will practice slab, which makes everybody believe if they see a crack, then we've done something wrong. So it'd be nice if that perception was worked with. Modulus elasticity, I used to own a testing lab. Our problem with that is, and from an engineer and contractor side, we love to see it on differential shortening or column shortening. Depending on the building size, on column shortening, modulus elasticity, creep, and shrinkage, right? Is what you'd like to see measured. West Coast, easy to earthquakes, we've seen some measured there. Our big problem with the owner is not necessarily the testing when the job's going on, because what's a couple $100 for modulus elasticity. The problem is, if you want to use a design, you've got to collect that information a year or two in advance. But what the owner doesn't like to do is negotiate with the producer or contractor. He feels it might eliminate his competitive advantage. So the problem is trying to get the owner convinced a couple years before the design, because if you get a modulus elasticity during the project, you're going to start redesigning? I don't think so. So that's the problem with that one, is in advance you can make it go. I've got a hodgepodge of stuff here because mine's lessons learned, which usually means somebody paid for these lessons. Fortunately, I didn't pay for many of them. I got involved in some. Since we're talking about tolerances and deflections with these two committees sponsoring this, I decided how am I going to link these two? What we hope, and we'll kind of abbreviate, sometimes we say we measure a tolerance. That's not quite right. We don't measure a tolerance. We measure something from a specified location or specified elevation, and we compare it to a tolerance, and the tolerance value in 117. Generally, we like to do that before the structure deflects. How many have ever been involved on the right-hand side where it deflects, and somebody calculates deflection and tells you whether you met your tolerance or not? Ouch. Thankfully, all these other speakers have already told us what about our deflection calculations and accuracy. On the right-hand side, I've seen some things where somebody says, we got to go out and measure the deflection. Deflection's 3 inches. The engineer comes out and looks at his design software and says, my design software says it's supposed to be 2.09 64734. And obviously, if I subtract those two, that's about 1 inch, and you only have 3/4 of an inch, therefore you were out of tolerance to begin with, which means you get to pay for our entire issue or problem, whatever it may be. And I say, well, that don't make sense. So I'd really love to see deflection estimates or calculations with like a plus or minus. 2 plus or minus 1 would be about right for me, okay? So let's move on and see what we can get from both ACI 117. And it has been mentioned that floor surfaces should be tested within 72 hours or before removal of supporting shores, obviously if it's suspended or elevated. And there's a couple things in 117 in a commentary. It says to avoid any possible conflict or susceptibility of the floor. It does say in the other red, slabs on ground with curl will change shape with time. What would be nice if it said in here, and deflections affect suspended floor slabs. So it'd be nice to put that in there so that we don't leave everybody guessing. So that would be a nice addition we could put in there. Deviation from elevation. We talked about floor flatness and levelness is measured within 72 hours or a time requirement or removal of supporting shores. I'm going to call that like an operational or procedural requirement. On elevation, our elevation on suspended slabs is before removal of shores, right? So again, we've got something covered there. So what does ACI 117 say? Straight edge and F-number, 72 hours. Straight edge and F-numbers on suspended slab, 72 hours, or an operation has to exist, right? Removal of shores. Elevation measurements, form surface before removal of shores, right? So far we're good. Well, what does 117 not say? This is only for floor surfaces. What about for columns, beams, walls? I don't know. The longest I can tell you that I've ever seen anything go to court was 15 years after the building was built, someone decided to measure where things were and decided it didn't meet tolerance. So can anybody beat 15 years? I think maybe somehow there's got to be some rationale in the process, but we say floor surfaces 72 hours. So we've got this forever problem in there. Also, we've got a problem. We say we are not going to measure the elevation of a suspended slab because of deflection, but we don't have that same requirement for slab on ground. So if the slab on ground curls, we don't like it because that affects floor flatness and levelness, and we say, no, you can't do that. But then somebody who's smart enough reads and says, I can measure the elevation at the corners and come back at you again. So it'd be nice if we kind of handled that one too. But we don't. So I think we may need to look at our timing and think about more than just floor surfaces and think about our procedural requirements and think about more than just removing the shores as an issue. So if we look at tolerance versus deflection, we're going to look at some wall issues. So is there a time requirement on walls? No. Is there any procedure requirement on walls? No. What about a temperature requirement? AISC, those sneaky guys, when they set up tolerances, they do what? Yes, they seem to think temperature is important. How dare they consider that, right? We don't. If it's 40 degrees out, we don't care. Let's measure. If it's 100 degrees out, we don't care. Let's measure. If the sun's shining on the wall and the wall might be bowing a little bit, it's time to measure, right? So we've got a few things that we might want to consider here. I hate to say we need to get as smart as the steel people, so I won't go that far. All right, let's look at some walls. So we've got some walls here, and we want to know what's happening. So I'll go through this quickly. Now would be an awesome time to measure tolerances for this wall, right? Let me tell you what I get involved with. We have a wall. It gets backfilled. Nobody measures the tolerances, but it's backfilled. And we've got all these different tolerances we can look at, right? And then we know that this wall tilts because we've decided to design it for active pressure anyway. And in order to get active pressure, it has to do some tilting. And there's estimates for the tilt. A 10-foot high wall, 120 inches, 0.01 would be, 1.2 inches? Just gives you a rough magnitude. So then we get somebody who decides to calculate the deflection of the wall due to the earth loading and tell us where it was before it got backfilled to tell us where our tolerances are. I cannot tell you how many times I've been through this. Because somebody didn't realize that wall with backfill wasn't going to stay in the same spot. Usually we'll just say architect. But so now they're looking for somebody to try and figure out what they're going to do with the walls not in the right place. And so I've looked at people on deflection calculations and said, what'd you do about the water or the ice? Or, well, I used the soil design pressure. And I'm like, okay, well, that's an envelope of a bunch of different things. I said, what about the equipment behind it? Did it happen to add any pressure when it was compacting the stuff? No.
Well, we think no. Okay. And then it's the question of how do you, is the stem wall cracked? Is it gross move inertia? Or I love the ones that use gross move inertia and decide it was fixed right here at the bottom. There is no base rotation. It's fixed. And I'm like, well, I don't know. I'll figure out, once you get a number, I'll figure out whether that's good or bad, but I don't really think that's the right way to look at it either. So when you think it's goofy, sure enough, when somebody has an issue, you will find somebody to make a deflection calculation. I really think it would help if we had something in print that says, this is not quite, this is almost like guessing in my view, but we've been here. Issues, retaining walls aren't the biggest issue because a lot of retaining walls, it's like, who cares where they are, right? What about this wall? Does it think it might make a difference if it got closer together? This is my very first introduction to issues, but look what happens if we put a train on there and there's rails on top of each one of these. That train is real sensitive when the rails start coming together as the walls push in. They start talking about things about derailment and this and that and everything else. So I just looked at it and said, I don't know where we're going, but this isn't going to work so well. So that was my first one. Location train rails, we got that. I think we know that. This was another interesting one. We've got this wall right here, and the question is, what are we going to do with this wall? Well, the architect decided he wanted to put his curtain wall on top of that retaining wall after it was backfilled, and he had a magical dimension in all the framing coming off of this framing over here. So obviously, when the wall got backfilled, then all of a sudden things got interesting because it moved a little bit, and the curtain wall guy wasn't happy with everybody. So it might be nice if we took a look at this and said, maybe we ought to measure wall tolerances. If we're going to make things be measured and suspended slabs before the removal of shores, maybe we want to make things being measured on walls prior to backfill operations. Hey, just a thought. Hey, either that or you get to watch some creative deflection calculations and have some people tell you where they think your wall was, what location it was in, how plumb it was, and everything else afterwards, which is kind of interesting. I chose a couple of these because I wanted to do horizontal deflections because I figured everybody was doing vertical deflections. It'd be nice if ACI 435 got into some horizontal deflections. I know everybody loves vertical, and I'll get there, but we do have some horizontal stuff. Post-tension slabs, we're trying to deal with this in 117. We've got a little bit in our compatibility document, but a time requirement and a procedure requirement. This comes from a Concrete Reinforcing Steel Institute document that says when we post-tension, we might get some horizontal movements at the end. Now, I know some contractors say, I'm not worried about that. I lean my columns backwards. I say, well, how much? Well, I don't know. I make a guess. I'm like, I think I'd ask before I start leaning them back and decided what I was going to do. But we end up with problems on the edges because of these goofy curtain wall installers. They think their curtain wall or facade is going to be straight, level, flat, whatever we want to call it, true. I love that word, true. So we get in there, and there is some movement on post-tension. This would be nice if 435 jumped into that arena a little bit. Here's a measurement. This one went to court. There's two lines. They're hard to see. One set by the concrete contractor, one set by the general contractor, and they were about a ½ inch apart, and everybody was arguing about who was going to pay for what on a later date. So we might have, in post-tensioning, maybe we need to have a procedure requirement too, or a time requirement. So we might have to take a look at that. It's not just a slab edge, because sometimes we have troubles with columns and plumb on columns and different things. The trouble is it's so structural system dependent, and it's so dependent on the length and so dependent on pore strips that it's really tough to give any good recommendations or general recommendations. It really needs to be project specific, and that's where we run into problems with that one. All right, where else do we need help? We need help with drainage, because occasionally that's going to be a problem. We have F-numbers, and all they tell us is the size of the bird bass, right? I mean, the lower F-numbers have deeper bird bass and more of them, and the flatter F-numbers have longer, shallower bird bass. A gap under a straight edge is just another word for how big or how deep is your bird bath. But we have a lot of people who don't believe that should exist. We have deflection bird baths, which can take a lot of birds, right? So one of the things we have is how are we going to handle deflections? And we could use some help. The parking garage people have some information, but they talk about consider camber and slope. The question is whether a structural engineer gets involved in the architectural slopes for drainage, and that doesn't always happen. And when it doesn't, it's not a good thing. Balconies. We'll go through this quickly because all contractors have balcony issues. We think the architect is sloping it at 1/32nd or 1/64th or 1/128th of an inch per foot or whatever he thinks he's doing, and then it happens to deflect and it doesn't go in the right direction. He gets all excited. Everybody gets excited. Structural engineer looks at it and says, oh yeah, I could have told you that. You should have told them about 6 months ago, 12 months ago, something like that. We also have the cantilever one, where we've got the issue with the backspan, and when that deflects, it comes back in. It'd be nice if we could get some help, because I've seen a lot of contractors do a lot of patching, run around in circles on balconies, but that doesn't work. So the last slide, what kind of help can we get from 435? It'd be really nice if it simplified some information for the rest of us, the user. There's a lot of detailed stuff in 435. Really be nice if they put out something saying a lot of the normal software programs aren't going to get you where you want to go for deflection calculations. They don't consider construction loads. Most of them are using 7.5 times squared F sub C prime because they use it in the cracking moment because ACI says you can, but then they use it in the deflection calculations instead of working back down to 4, as they suggest. I would consider a plus or minus on any deflection calculation. I'd like to say plus or minus an inch instead of 6 decimal places. I'd like to stress the difficulty in going from a deflected shape back to try and decide what your tolerance is. That would be really nice. And the last one I'd like to say is these limits, these are in table 9.5C, so some of the designers know which one that is. These limits apply to the domain of previous experience. Right now we have owners asking us for a whole lot more than what we've previously done. They're asking us for a whole lot more in serviceability, and I don't think the design side or the information from ACI has kept up with it. These sessions are awesome because what you're hearing is people who are on the leading edge and is caught up with what people want. Our issue usually isn't with people in this room, it's with people that don't come to ACI, haven't looked at 435, haven't looked at 117, and that's a huge educational process. So with that, I am done. Thank you very much.
Yeah, you got time for questions.
Wow, I did? I thought.
It's 1 o'clock. If anybody has any questions, feel free to go ahead and ask.
Yeah, so I had a question. Everything you're saying, I get it all. It seems like you're harping a lot on more measurement is important. Can you speak to that at all? I mean, how would you think we should, as engineers, integrate this into spec standards in a reasonable way to get better information?
It's a really good point because we're discussing that in 117. We discuss it in American Society of Concrete Contractors. We've got a little bit of an issue because most owners will pay for F-number measurement, okay, FF and FL. The testing lab does it. It's already in the testing scope, so they pay for that. The difficulty we have, and I used to own a test lab, is you don't necessarily want the test lab to be the surveyor. Sometimes they don't have the equipment, sometimes they don't have the skill, and construction surveying is totally different than land surveying. So a lot of specifications, quite frankly, are putting it on the contractor to do the construction surveying, which is okay. Some contractors are starting to do it now, recognizing the problems they've had, where they're taking their own measurements. The question is, what can we do with those measurements? Can they really be used for acceptance or rejection since the contractor took them? So we are seeing, as an engineer, we are seeing requests, or actually specification requirements that make us take them at different times, when the shores are in place, after the shores are removed, and 6 months later. So you can collect the information. The difficulty is, what do we do with that information on this project? It really helps on future projects, but yes, at this point, we haven't got it worked out as to whether an independent party is going to do it or the contractor is. I would, at this point, if I was an engineer specifying, I would ask for the information, because if I'm doing 10 stores, or 32 stories, I got a chance to adjust to make it better for the owner. If I'm doing 3 stories, by the time I get the information, I'm probably done on 3 stories, right? So that's the difficulty we're having is who can do it, how much is needed, and whether we have to hire an independent surveyor.